Okay, solar photovoltaic system. Grab my pointer here. Like I said, guys, last part of the semester, the fall semester, we talked about the residential and the whole solar photovoltaic system and wind energy is becoming so popular in the US because of energy conservation plus affordability. So because of all of that, we had done what we had 6 panels. I don't know if you guys have seen them. If you go to my YouTube channel, Steve and I installed 6 panels on the roof, 10 panels on the roof for I think 3.5 kW or not. Imported into our lab right now. If you can go there, you'll find them. So great, great addition to our electrical program. A lot of companies, guys, are installing these solar photovoltaic system on their roof. So this chapter will talk about how to utilize them and what's not. There's a couple of systems we will talk about in particular, but this one is called utility interactive system, meaning if the utility is not there, this system will be completely shut down. That's what utility interactive system, Derek, is. Means this solar photovoltaic system will work only if the utility is there. If the utility is there, it will shut down. This system shut down. Now you can add another system where you can have battery backup, charge your batteries, and then use your batteries as your backup. Okay, a couple of things, guys, about solar photovoltaic system that I'm going to talk about is components. What are the components that make a utility interactive solar photovoltaic system? I wanted to introduce a solar photovoltaic system, Derek, to this project, but knowing how much things you guys have to do, it would be a little bit too much to add another solar photovoltaic system on a roof of the building that we have, that 10,000 square foot commercial building. And wiring it. The wiring calculation is not a whole lot, but I thought it's a little bit too much. So hopefully one day we can do that. Function of the utility. How does the utility interactive system function? So describe the function of utility interactive solar photovoltaic system. How does it work? And then of course you can't do anything without the Bible, so you need to go to the National Electric Code. So it tells you how to design the system. You guys are the designers. I'll tell you very easy. You're going to see, guys, when we look at the design part, the multipliers they use to size the system, very easy, the code. And the installation. And the installation of the commercial, it really doesn't matter if it's commercial or residential. But in this case, with a focus of commercial. The code requirement for design and installation of this system. We'll talk about this one. With you guys are designers, so if familiar with single line diagram or one line diagram, that's what you did yesterday with me, guys, on a scam. Solar photovoltaic system have something called a single line diagram, which shows all the panels tied together to the combiner. You'll see what a combiner is, and taking them from the combiner into the inverter, and from the inverter into the power system, your power system, which is typically the grid. And in between, there's a bunch of conduits and disconnects and labels. That's what the riser will show. Okay, so I don't know how many of you guys utilizing the sun to generate electricity. It's nothing new. I mean, there's calculators that have been used, guys, solar calculators. I don't know if you use, most of the calculators have been utilizing photons from light to power these calculators for many, many years. And if you read a little bit about history, it probably the earliest history is 1950s, utilized, NASA utilized it and what's not. Now, it has been utilized to generate electricity in the 70s and 80s. I believe in 1984, solar photovoltaic system article was introduced in an EC code book. When it's introduced in an EC code book, it becomes kind of more popular, more enforceable and what's not. So it has been there for a long time. It's used all over the world. In the US, it became very, very popular for the last 10, 15 years because of affordability and because we care. We're starting to care, Adam, much, much more than we used to about Mother Nature and the frogs having 4 legs instead of 3 legs. Right, Derek? That's for my wife. So why did it accelerate recently? Because of the energy conservation. We're becoming more environmentally friendly, rightfully so, and the environmental concern now becoming green. I know some of you might agree or disagree. I don't like to talk politics, but green, guys, is becoming green as thinking green If you go to Michelle Cooley Erickson and you say, I don't believe in thinking green, that will hurt your career. I'll guarantee you. In the past, it used to say, well, green is not a big deal, and you know how our attitude in the US is a little bit different. But now, there's certification, guys. If you go to any engineering company, you will be certified as a green designer and lead accredited professional. When you go, Adam, at Michelle Cool Erickson, the last couple of years, 4 or 5 years, they have accredited tons of people to have lead accredited professional in order to get more business. We're smart, we know how to do it, we care about the environment, and hire us to design your building. So it's a big deal. So I want you guys to take it very serious. It's a big deal to be a lead accredited professional, meaning you design taking the environment in consideration and conservation. Energy conservation, guys, you have done ComCheck with me, Karen, and part of ComCheck and the U.S. Department of Energy now, and all the states adopting the energy codes. In Minnesota, we have an energy code, an ASHRAE 90.1. All this, guys, is part of the energy conservation. Anyway, part of the whole initiative is solar and wind, bringing solar and wind clean energy. So chapter 1 through chapter 4 of the NEC code book, guys, applies to the installation of solar. And because of its unique application, there's also another chapter or article dedicated to a specific requirement of installation and design directly related to solar photovoltaic system. And because solar photovoltaic system is interactive system with other system, we have Article 705 that tells you how do you tie two power systems together, like generators and grid. 705 will tell you how you tie them together. So these are what we're going to be talking about, guys. The heart photovoltaic effect. The heart of the photovoltaic system is what they call them, Adam, is photons. You probably heard that one in the science classes. These photons are absorbed. When they're absorbed by certain material, by specialized combinations of semiconductors, thank you, Mother Nature, for the semiconductors, which is a diode. When they're absorbed, when these photons, guys, absorbed by semiconductor material, they produce electrical current. Welcome to generating electricity through DC. Most of the time, Karen, a lot of energy is generated through rotating machines. So either you burn coal and you have a big turbine that you rotate and you get electricity, or you split nuclear plants, and you churn energy, you boil the water, steam it, and you run the turbines. That's what most of the power that we use, guys. Obviously, or wind, make the wind run a turbine also that runs it. Photovoltaic generated electricity is slightly different by utilizing the photons that hits a specific material called semiconductors, diodes, and when it hits it, a natural phenomena comes out of it, which is a tiny little electrical current, DC current. That's it. That's how they generate it. Here's the two material semiconductors that they use, guys. Crystalline silicon. Again, thank you to silicon. That's what they use in your laptop too. I always get amazed, guys, when I teach basic electricity. If you have fully insulated material, great, because we can insulate the conductors. If you have very conductive material, Derek, it's great because that's how we use the copper and conductors, wires. And if you have a material that's semiconductor, not very good conducting, not very good insulation, they call them semiconductor, and that's the birth of the whole digital world that you use, all these laptops and anything digital, including the solar photovoltaic system. So I'm so thankful to the smart people who discovered all these a long time ago. Anyway, so you put all these semiconductor material, guys. Of course, you have to fabricate them into wafers, infuse them with phosphorus gas, and they generate all these solar photovoltaic panels that you see. So the heart of the solar photovoltaic system is the semiconductor material. Back to the silicon. Any comments, guys? Any question? You have the light hitting these semiconductor material. It generates current. You collect all this current and voltages. It's a small current, guys, on the cell, but as you put many cells, you collect them, and you get yourself a voltage that you can utilize. Okay, these guys, they produce solar photovoltaic system, guys, direct current when exposed to the sun. So in order to, we don't utilize direct current, Karen, a lot. There is a lot of application for direct current, but in the power industry, the dominant is the AC thanks to Mr. Tesla when he won the war against what? Edison. Yep. So now we're going back into Edison time. So, but the power distribution system internationally, guys, right now is the dominant is AC. Now, in order to utilize that DC source of power, you have to have something called inverter. Inverter, this guy converts that DC that you have generated into an AC, alternating current, and also synchronize it with the utility. You have to, not only you have to, the interactive inverters guys have to do two functions. They have to convert the DC into AC and synchronize it with the grid, because if you don't synchronize it with the grid, you will blow up your system. So then you synchronize it with the grid. Then when you synchronize it with the grid, either you utilize it in your plant or you can shoot it on the transmission distribution lines to sell it to Excel with certain agreements. You can also store the energy in batteries for use when there is at night when the sun goes to sleep or overcast days when there's no sun. There is also solar photovoltaic system with interactive guys. Either you shoot the power through the grid when the grid is there. What happens if the grid is down at night? If you have an interactive, when the grid when the sun goes down, guys, you are connected to the grid, so you get your power from the grid. If you are a standalone system, what they do with a standalone system, guys, there's no grid. You live in the boonies and there's no grid there. What they do is they have backup batteries. So you charge the batteries at night, you utilize these batteries. Any comments, guys? Any questions about utility interactive? But utility interactive, guys, typically it works if the grid is there. If the grid is not there, it doesn't work. Okay, here's how the system is made up. The heart of the system, guys, is solar. The solar cells, these semiconductors that you hit them, they collect the current. They connect all these solar together, solar panels, positive to negative, guys. They make, they put multiple solar into them. They make modules. They put multiple modules. They make a panel. I don't know if you guys can see from a cell into a solar into a module into all my panel here. When you connect multiple panels or multiple modules together, you guys get a string. And you tie these strings together. I don't know if you can see right here. You put a fuse on them. You put a diode so they don't shoot the current back into each other. And you collect them. You collect multiple strings here, and you take them all the way into your inverter. Here. Inverter. From your inverter, you take them into your grid, and you tie them to your grid. That's how they do the solar photovoltaic system. Any comments, guys, about the DC solar photovoltaic system? I want to bring to your attention, guys, something called solar photovoltaic circuit here. Solar photovoltaic circuit. Photovoltaic output circuit here. Blocking diodes that does not allow the current to go from panel to panel. It goes directly into the inverter. You combine them together. So this will be my combiner where I combine all of them together, all these strings together, and bring them to the inverter and shoot them to the grid. Any comments, any questions? Gentlemen, ladies, any comments, any questions? So that's your solar photovoltaic system, from the solar cell to the modules, tying the modules together. And Adam, they're like batteries. You take positive to negative, positive to negative, positive to negative. When you add them up, guys, you get yourself different voltages. So if the voltage is, say, 24 volt, and you put two voltages, 24 in series current, you get 48 volt. You keep adding these voltages until you reach the desired voltage for the inverter. Then you start putting them in series, the strings in series to get you more current. This is the DC. This is what they call the DC generation. There's also AC generation, guys, where the panel itself, we have one in the lab right now. If you go to Steve's lab, there's one there, has an inverter. So the AC module have an inverter, guys, built into it. And then you synchronize all these inverters, and you get it here as an AC signal. We generate here as a DC signal. On the AC inverter, we generate them as an AC signal. Any comments, guys, about the AC panels or AC modules versus DC modules? The AC modules, here's a module here. There's a little inverter here. It takes the DC and invert it to, let's just say, 240 AC, right here at the module. The DC module, guys, it will create 24 volt DC here, and then you have to pull it with wires all the way, tie it to a couple of other panels all the way to the inverter. So that's a DC module versus AC module. If you go to our lab right now, we have both of them. We have AC and DC modules. Any comments, guys, about the modules? I can't emphasize. We start with the cells, but multiple cells in series, guys, get you a certain voltage, say 24 volt. Get multiple 24 volts together, it gets you 48, or keep adding all these modules together, whatever voltage. And each one of them, say, each one of these cells, say 200 watt at 24 volt, 200 watt. So the more panels you add, say 10 panels, I'll give you 2000 watt. You need another 10 panels, I'll give you another 2000 watt. Here's a 4000 watt. Does that make sense, guys? Each one of these panels has a watt and a voltage. How do they make the voltages add up? Very simple. Here's each one of these panels, guys, has a positive, negative. Here's another panel here, a negative and a positive. So when you tie these two together, negative to positive, you come out of here. If this is 24 volt and this is 24 volt, and this is, each one of them is 200 watt, 200 watt. The system, the output of that system, guys, will be 48 volt DC, and 200 plus 200 is what? 400 watt, right? Now, if you need more watts, what do? You keep adding them. Any comments, guys? Any questions how they get the voltage? So, Derek, they get the voltage by seriesing these panels, and they get more current by paralleling them. Here's string number 1 has, say, 200 volts. String number 2 has 200 volt. You tie positive to positive, negative to negative, you got yourself 2 strings. And they tie these strings right here. So when you see that point here, this is positive, this is negative, and they connect all the negative together, and they connect all the positive together here, and then they take it. That's your so-called your combiner. They combine it. Okay, so that's my solar photovoltaic system. Here's a good explanation for that one, guys. Here's all the strings coming, solar photovoltaic system. You bring them to the combiner, you combine them, you bring them to the inverter and invert them. I want to, right here, guys, I want to do a couple of calculations. The way they size these conductors, they take it they have 1.56, I believe. 1.56, and they size the conductor based on the short circuit. Yeah, 5.6. 1.56 times I short circuit for the panel. So they take the the current of the panel. Say this panel is 1 amp, and they multiply by 1.56. So why 1.56? This 1.56 is, guys, combination of continuous load and a special operation of this solar photovoltaic system. They tell you because specially, so continuous load 1.25 plus another 1.25 gets you 1.56, and that's how you size your conductors here. The same thing, Adam, also you size your conductors right here. The output conductor, photovoltaic output circuit, based on 1.56. You go to the inverter here. Now here's my inverter. Now you size it based on 1.25 multiplied by I, output of the inverter. That's AC. Now this is the AC. This is my DC side, right? The overcome protection device, the same thing, 1.25 times I out of the inverter, output of the inverter. Now, Karen, they also have DC disconnects here. There's a DC disconnect and also AC disconnect. The same thing, guys, the disconnect 1.25 times I out. And for this for this particular 1.56 times I short circuit of the whole system, of the whole modules. If you have a fuse here, which typically they have a fuse, they size the fuse 1.56 times I short circuit of the modules. So on the DC side, can I guys get you to understand one? On the DC side, when they size, they multiply 1.56. On the AC side, when they size things, they multiply by 1.25. For disconnects, for fuses, as well as for disconnects, overcome protection device, as well as conductors. Any comments, guys? Any questions? Any comments? Any questions? So you have your solar coming in, utility interactive. You can see there is no storage. That's called the interactive system. That's what we talk about. There's something called hybrid, guys, where you can tie to the grid, and also you have DC. You can get utilize it at DC load, and you also have another source of power here, generator or what's not. Plus, so we have solar, we have generator, and we are inverting to the grid here. And you have standalone. Adam lives right in the middle of nowhere and he doesn't want to be on the grid. So he built a solar photovoltaic system here and feed his loads at a DC level or at an AC level. Any comments, guys, about the three types of solar photovoltaic system? Either interactive, you tie to the grid, or hybrid, you tie to the grid and you also have another source of power, like a generator, or standalone, where you do not tie to the grid, there is no other source of power, and you're just taking the solar and storing it into batteries and utilizing it at night or when the sun is not, when in a cloudy day when the sun is not there. Any comments, guys? Any questions about these systems? Comments, questions about the systems? So remember, there's a lot of disconnect you're going to see and what's not. Okay, so the heart, this is just going over what we said, guys. The heart of the solar photovoltaic system is called the modules. That's how you generate the basic building block of the system. Individual photovoltaic semiconductor cells. It puts all these semiconductor cells, guys, together, electrically connected together in one unit. All the cells, they connect them, they fuse them together into one cell. They are different in sizes and in cost as well as in efficiency. So you say one of them says 24 volt DC at 250 watt. So you can buy them at different voltages, guys, DC voltages, and at different watt, 18, 50 watt DC, each one of these panels, okay? And each one of these panels, gentlemen, looks something like this, and it comes with a positive and a negative, and 24 volt and 200 watt. You are looking at this module connected. So why do we have two wires coming out of it, one positive, one negative? So you can tie them in series to get more voltage, or you can tie them in parallel to get more current. Any comments, guys, about the modules? That's the panel. That's the panel. If anybody's interested, Derek or Karen, if you guys want to, we have a class that we're offering solar photovoltaic system, how to wire them and troubleshoot them and what's not in electrical construction. Array, then we put all these panels, collect all these panels together in a complete photovoltaic generation plant. And this is a fancy name for, here's a bunch of them, guys, sitting here, a bunch of them. And for the ease of installation, so here's my positive, negative, positive, negative, positive, negative, positive, negative. You tie the positive to the negative of each one of these like batteries, and you take them out of here. Let's just say these were 20 volt, 20 volt, 20 volt, 20 volt, 1, 2, 3, 4. 4 times 2 is what? 8. The system here will give me 80 volt DC. Each one of these is 100 watt, 100 watt, 100 watt, 100 watt. Now the system, when you add them all up, will get you 400 right here, 400 watt. Right? That's how they do it, guys. That's what the array is. So we have a one string, they call it string, Karen, that has 480 volt DC and a 400 watt or something similar. If you need more, what they do, guys, is they start tying these two together and adding multiple here. Same thing, here's another 4, tying them together and coming from this. Here's string 1. This is my string 1, and this is a string 2. Oops, this is string 1 and string 2. String number 2. And this is string number 1. So we have 2 sets parallel together. Combination box, combiner box, they take these 2 strings, guys, out of these modules, like I said, and they tie them together. So here's my negative, here's my positive. This is the dots, and they start all the negative coming together, all the positive coming together of each one of these strings. Any comments, guys, about the array as well as the combiner box? We do have in our roofs right now an array made out of 10 panels. We divide them into 5 actually, and they're making 2 strings, and they're bringing them into the system as a 2-string system. That's your solar photovoltaic system. Now with solar photovoltaic system, guys, you need disconnects. You have to have disconnects for safety. You have to have disconnects for the inverter, on the DC side and the AC side. You have to have disconnects when you tie to the equipment. You have to disconnects for the array. So multiple disconnects are required for all these systems. Disconnects for all these systems. These are the disconnects for the system for safety. Inverter, the job of the inverter, Adam, is to take a DC system here and take it into an AC system. That's the job of the inverter. Convert AC to DC. And also, interactive ones, they automatically synchronize with the grid. They synchronize the AC with the grid. So they give you the same magnitude, same frequency, so you can synchronize it with the grid. Any comments, any questions? Do you guys remember when Jerry Boggs was here and he said when you put generator on the grid, you have to synchronize it? Same thing. You're putting a generating plant on the grid, tying it to the grid, natural grid, electrical grid. You have to synchronize it. Okay, inverters. The inverter, guys, by UL 174 and NEC code book require these interactive inverters to have something called anti-islanding. Anti-islanding meaning if the utility is to go down, you are to disconnect yourself from the utility because we don't want you to feed back into the utility when the utility is down. They call it anti-islanding. Turn off utility is lost, so you have when the utility is lost, you are to turn off your system. That's what the anti-islanding is, okay? They also require you to provide ground fault protection. You have to provide ground fault protection for your solar photovoltaic system. So you have a device that since they have a ground fault, alarm that you have a ground fault, and disconnect the grounded faulted part of the system. Typically part of the inverter, guys. So if you have a ground fault anywhere, ground fault positive to ground or negative to ground, this device will sense it and interrupt it as well as alarm because you don't want to create fire. And if your system is over 80 volt DC, then the code requires you to have an arc fault. So if there's an arc on the DC side, your inverter should be able to recognize the arc, alarm that there's an arc, and disconnect the circuit that's arcing. Any comments, guys, about the arc fault circuit interrupter and the ground fault protection on the solar photovoltaic system? Solar photovoltaic system. I was hoping one day we can design the system, guys, but one day. So it's really designing is really not hard. All these arc, Adam, and ground fault, these are part of the inverter. If you go to the inverter in the another motor lab, the wiring lab that we have, right on it, it has the capability of ground fault and arc, sense the arc. Okay, so that's it basically. You take the solars, you combine them together with a combiner, multiple disconnect for safety, invert them with an inverter, and dump them into the grid so you can feed your house as well as other neighbors. With an agreement with the grid. There's something called site or plot plan, guys, indicate the geographic location of principal PVC component and existing electrical service. So when you have, because you're putting a plant, you have to have a plot where it shows here's my solar photovoltaic panels are going to be located right here, and here's my inverter is going to be located right here, and here's my wiring methods, guys, coming in here, and I'm coming all the way here and connecting it to my main panel. That's showing your site plot and showing all how the feeders are coming between the inverter. Here's my inverter coming in here. Here's my panels, my solar photovoltaic panels or the array of panels. So it shows all the location. Then you have a single line diagram that shows the point-to-point wiring for all these electrical schematic diagram for the utility interactive voltage, and you're going to see it in a second. Okay, here's how the system is wired, guys. Here's your solar panels, 28 volt, each one of these 28 volt. They bring the positive, can you guys see the positive and the negative? They have a disconnect here for safety. They have an overcome protection device on the positive typically side. You bring it to the inverter, invert it to 240 volt. You have a disconnect, an AC disconnect here, and then you bring it into the utility and you have another AC disconnect for the utility. And that's how you feed your power into the utility. Any comments, guys? Any questions? They also have an equipment grounding conductor, typically number 6, guys, that you have to ground the inverter and ground the panels with number 6 copper, going all the way. I want to bring to your attention, guys, in terms of sizing, the wires here as well as the fuse here. When you size it 1.56 times I short circuit for the panels, as well as the disconnect, as a matter of fact. Now you go to the inverter side here, 1.25 times I, output of the inverter. You size the disconnects, you size the wires, and you size the overclock protection device. All these are sized 1.25. Any comments, guys? Any questions about the riser? You connect them. I have 281, 2, 3, 4. What's 4 times 2? 280, 240. 4 times 2 is what? 8, so that would be 80, and 4 times 8 is what? 32. So that will give me, help me here, 112. Can somebody do it? My brain is sleeping today. What's 28? Can somebody multiply 280 by 4, please? Yeah. No, 28 by 4.
28 by 4?
Yes, sir.
Yeah, that's 112.
112, that's what I thought. 112 volt. So here's that 4 modules, guys. It'll give me a 112 volt. That's your voltage here. Any comments, guys? Any questions? This applies to us, guys. The colder the weather, the more voltage the panels will generate, believe it or not, the colder the weather. So there's a bunch of tables, guys, that allow you to modify this voltage based on the temperature. In Minnesota, it was -2 today. Was it -2? You go to -2, there's a table will tell you today like this. The lowest temperature encountered in Minnesota, say -25. Based on this lowest temperature, the voltage will be sized. Excuse me. They call it open voltage for the panels multiplied by a factor. I'll show you in a second. I want to bring to your attention, guys, the grounding electrode system that you have to create for the DC, as well as the grounding electrode conductor, which is typically number 6 here. And you do have to tie the 2 grounding electrode system for the AC and the DC together. The AC and the DC together. Really not a whole lot to it. And then you send the power. Here's how you do it. The power will come in here, go to Excel, or come in here and go to your plant. The power will be utilized with agreement between you and Excel, goes to Excel, power your neighbors' homes, or come to your house and power it, or your plant. Calculations. We talked about the calculation, guys, DC calculation. For DC calculation, they have something called open voltage. So voltage open circuit voltage is 28. That's the voltage that they use. Maximum DC current is I short circuit, when they short circuit the panel, and that's the current that they use for calculation. And we talked about multiplying this value by 1.56 to size everything. On the AC side, sizing component for inverter, guys, the keyword one is continuous load. Multiply this one by 1.25 for disconnects, fuses, as well as circuit breakers. Ambient temperature correction for conductors. Because these conductors typically goes in the roof, you have to take into consideration ambient correction for conductors, as well as if you put them on closer to the roof, there is a derating factor for closer to the roof table that tells you guys you have to derate the ampacity if you put them too close to the roof because of reflected heat from the roof. Then you have the mounting of the arrays, a modular, so you have to mount them. They are typically framed. They use aluminum frames, guys, because it's light to mount all these panels on them. And you can go and look at them on our roof here. Grounding, we typically use number 6 copper grounding to tie all these modules, arrays together. Installation of combiner, you have to have a combiner, which is basically a junction box with certain fuses in it to combine all these strings. If you have large equipment and if you have panels, you have to pay attention to the clearances in the front of all your panels. Grounding electrode system, you are to create a grounding electrode system, guys. If your equipment are on the ground, you have to drive a ground rod there and tie to it. If your equipment are on a roof, you typically have number 6 and you tie it to the closest grounding electrode system in your building. Wiring methods, all the wiring methods approved in any sequence book can be used there if it's approved for a wet location or direct exposure to the sun. Direct exposure to the sun. If they're direct exposure to the sun, they have to be rated for that. If they're in a wet location, as on a roof, they have to be also listed for wet location. So that's a few things, guys, about connection. Utility point of connection. Where do you connect? You can connect on the line. Here's my 4,000 amp switch gear, guys. 4,000 amp. I can connect here, and this is my solar system, or I can connect here, and this is my solar system. This is the line side. This is the load side. With agreement with the utilities, you can either put it on the light side or the load side. There's a lot of labels, guys, signs and equipment marking. Tons of labels. You have to label all your feeders. You have to put signs for all the disconnect. All your disconnect AC and DC must be labeled as photovoltaic disconnect AC and DC. The inverter have to be labeled with the voltage that's coming in, the voltage that's coming out, and the rating of the inverter, labels by the manufacturer. The disconnect for the photovoltaic system have to be labeled. You have to have a label. The cables, if exposed, the wiring, DC wiring have to be labeled, photovoltaic wiring, the written feed, so to save the people from cutting into it. And in 2014, Adam, they introduced shut-off, emergency shut-off. They want to have these a push button like this. That was in 2014 when you can slam the push button and it shuts down all these panels. So you have a little relay with every panel. It shuts down every single panel. If there's a fire in the building, firefighters pulls in, they shut down the electrical power, but the solar photovoltaic system is still cooking, right? How are you going to shut it down? Even if you shut down the disconnect, guys, still generating. So you need to go shut down the panel itself. So they created in 2014 a push button, you push it, and it de-energized every panel. So it's really interesting to see how that goes. Okay, this is how you can tie, guys, to the grid. You can tie, this is the line side. So this meter will be called bidirectional. Then you can buy a bidirectional meter and agree with Excel, guys, that you can sell them certain amount or buy certain amount. There's different utilities, guys, can give you different agreements. Some utilities will give you an agreement that's worth nothing. So that's you have to coordinate with the utility. You need to have a fuse disconnect, guys, put inside. You have to label. So all these have to be labeled. Also, you have to label at the disconnect. You have to have a label right here at disconnect that says photovoltaic system exists. Another source of power exists. After you did all this thing, Adam, you need to do commissioning for the system. Before you energize, perform thorough inspection of the whole system. Everything is connected. All the conduits are and the boxes are mounted properly, or connectors are torqued properly, and what's not. Once the system is operable, some calibration, then you do the inspection, guys, before you energize it. When you start operating it, you have to do some calibration to attain the maximum performance of that system. So there's some tweaking in the inverter that has to happen to make the system work properly. So that's basically what the solar photovoltaic system, gentlemen, is. And that's enough to get you up and running. So we talked about this one, guys, how they generate it. Let me see if we forgot. We talked about the different system, interactive system, hybrid, where you can bring another system as well as the standalone. We talked about the components where you can series the panels to get you higher voltage. And you can then, this will be one string, add another string to get you more current. Dump them into the inverter that must have a capability of detecting the ground fault. And then you have multiple disconnects you can see on the AC side and the DC side. Then you dump it right into the grid, either on the load side here or on the line side right in the top here. So that's what and then there's an equipment grounding conductor. Equipment grounding conductor that has to come with them, and a bonding conductor and a grounding electrode conductor for all these systems. You can feed, like we said, you guys can feed on the load side right here. There's limitation on how much you can do here. You cannot exceed, if you're feeding it on this side, guys, we talked about this one before. So if this is, say, 125 amp, this must be 100 amp, and then you're limited here to 25 amp. You cannot exceed, the bus cannot be more than 125 amp of what you're bringing. So there's limitation on how much you can put right here. There's limitation on how much you can put in order not to overload your system. So that's And you can, if you feed on the line side, who cares? You can feed as much as the utility can allow you, and the circuit breakers between you and the utility are allowed to do. Here's a bunch of solar photovoltaic system, guys. Utilities are getting into this business. If you put them on the ground, Adam, you have to drive a ground rod and tie them to. Here's the combiner. I don't know, you can bring all these strings right here, guys. The positive, break them. There's fuses here, and then the negative, tie them all together. Tie all the negative together right here. The positive are broken, and then you bring the black and the white conductor, and you go to your inverter. So from multiple strings. Then you bring your inverter here, and you invert them into AC system. Here's the power, guys. Look at all these. This is a huge plant that's on the roof. You have to mark these, and also you have to derate when needed. If you mount them on the ground, there is a frame that you have to put them, typically aluminum, anywhere. If the voltage, they also have voltage correction for the open voltage, guys, because of temperature. Let's go to Minnesota and do some correction. Can you grab your calculator while you do one connection for me? Let's say we're in Minnesota, and we encounter the lowest is minus 25. Then my correction factor, oops, not Celsius. I'm going to go with minus 25 right here. I'm going to the Celsius side. Let's go to the Fahrenheit side, guys. And here's minus 25 Fahrenheit, right? Here's my Fahrenheit. My multiplier is 1.25. So Adam, if my voltage, open voltage for a panel, here's a panel. My open voltage, positive, negative, is, this is 28 volt, okay? 28 volt. Because we put it in Minnesota, the voltage is going to be 28 times 1.23. Can somebody do that, please, for me? 28 times 1.2. How much?
34.4.
34.4 volt. Now that 28 volt, guys, now is 34 volt. Because lower temperature pumps more voltage. Why do they take this into consideration? Because if you don't take it into consideration, you will exceed the temperature rate, the voltage rating of your equipment, and it will become dangerous. So that's how they correct the voltage, Adam, based on the temperature for solar photovoltaic systems. If you install things on the roof, guys, on the roof of a commercial building or residential building, there's reflected heat. Then the temperature, you have to adjust for temperature. For example, let's just say you went and we use this one, guys. You put it up to 3.5 inches. You have to add 22 degree Fahrenheit. Say in Minnesota, it's 90 degree Fahrenheit ambient temperature. So that will get in Minneapolis. That will get you 112 degree Fahrenheit. And this is definitely more than 86 Fahrenheit, 86 degree Fahrenheit. Who cares? You need to go derate. Remember the derating, temperature derating? You need to go derate based on the height when you put them on a roof. If you bundle, remember this is, you guys have done that. When we bundle, we put more than 3 carrying conductors. AC or DC, you need to derate. So these are the derating. And that's basically it, guys, in terms of solar photovoltaic systems. A lot of labels, a lot of calculations that involved, but the chapter, the system is it's not a whole lot. So any comments, any questions? Comments, questions? Comments, questions? When you get involved in a project, I don't think Mashad have done any solar photovoltaic system that I know of. When you get involved in a project, guys, I would encourage you to read this chapter and review the article that talks about it too. Article 690. Not a whole lot to it though. A lot of disconnects. You have to learn how the DC, and if you, Derek, if you ever work with batteries and you put 2 batteries in series, 1.5 give you 3, right? You series them, give you 3 volt. That's what that's panels are. 24 volt in series will get you 48 volt. Keep adding, like batteries. But there's a limit how many you can add though, because you keep adding, the voltage becomes so high, the inverter can't handle it. When they reach the limit of the inverter, what are you going to do? You still need power. Instead of adding batteries now in series, they start paralleling the string. So here's 5 panels in series to each other. Here's another 5 panels. What they do then, they put them in parallel. They put the positive to the positive and the negative to the negative. They start adding current after they reach the desired voltage. So it's Not a whole lot of rocket science into it. Gentlemen, that will wrap up. Everything is easy to you, Chad, huh? It really is, not a whole lot to it. That will wrap up, my friends, our lectures for this semester. And you will be tortured with other lectures next year with your friend Chad. So, all right. So I would like to give you guys maybe 10 minutes, and then we'll review for the test tomorrow. It shouldn't take that long, you know. Should we good? I want to remind you guys I need homework, especially for the lighting. If you are to get credit today, I need the homework for lighting today because I'm going to put the homework on the network for you. So just quick reminder. Thank you.